like some basic concepts. Okay, so let us go through these basic concepts. Yeah, some recapitulation. Integration of vectors. So when this f of t is any vector, and that small f of t is the another vector, the differentiation of that cap f of t is equal to that f of t. So then the integration of the small f of t dt is equal to that cap f of t. So that means its integration is this. If the differentiation of f of t is f of t, so then integration of this small f of t with respect to t is capital F of t. So you can add the constant also. Suppose when c is the constant, c means here c is the vector. It is the constant vector. So then differentiation of d by dt of f of t plus c is equal to, that is same as d by dt of f of t. So which is equal to the differentiation of that capital F of t is the small f of t. So integration of that small f of t dt is equal to f of t plus c. That means, so when you are taking the integration, you have to take, we can take the constant. Here this constant means that is the constant vector. Okay, some more results. So suppose f of t and g of t are two vectors, vector point functions, then integration of f of t plus g of t dt is equal to integration of f of t dt plus integration of g of t dt. Similarly, the second property. And next, if f of t is equal to f1 of t into I, f2 of t into j, and f3 of t into k, that is in vector form, that is a vector point function. So then its integration of f of t can be written like this. So I into integration of f1 of t into dt, j into integration of f2 of t into dt, plus k into integration of f3 of t into dt. Like that we can write. And also we have d by dt of r dot r, where r is the position vector at any point on the curve. So then that means you can take that r is equal to xi plus yj plus zk. So in that time, the d by dt of r dot r is equal to 2r dot dr by dt. So the integration of 2r dot dr by dt is obviously that r dot r. So that is r dot r plus constant. Similarly, that another fifth result, d by dt of r cross dr by dt is r cross d square r by dt square. Here cross means that is the cross product of the vector r and dr by dt here. So therefore integration of r cross d square r by dt square, it with respect to is equal to that same r cross dr by dt plus constant. Here constant is the there. So to understand the line and multiple integral concepts, we should know some basic concepts on curves. So what is a closed curve? So when you say curve is closed, if the initial point and final point of the curve is same, then we say that curve is a closed curve. For example, circle is a closed curve, rectangle is a closed curve, and a triangle is also a closed curve. So what is meaning of a smooth curve? Smooth curve means that curve is differentiable. Then we say it is a smooth curve. In another sense, so a curve is said to be smooth if it is possible to draw a tangent at all the points. Then we say the curve is a smooth curve. So for example, mod x, of course, y is equal to mod x. So that is y is equal to mod x is a curve. It is a continuous at 0, but it is not differentiable at 0, because you see, if you draw this curve, so at 0 it is not possible to draw a tangent. At origin it is not possible to draw a tangent. That means that curve is not smooth at x is equal to 0. So like that, a smooth curve means a curve is said to be smooth if it is differentiable, or in other words, a curve is smooth means we can draw a tangent at all the points. For example, this one is the smooth curve. Okay, so that means we can draw a tangent at all the points. Piecewise smooth. So actually that curve is not smooth, but we take some parts separately, so then it becomes a smooth curve. For example, if you take whole rectangle is not a smooth curve, but if you divide that rectangle as four line segments, so then it is a piecewise smooth. It is a combination of four smooth curves. So like that triangle is a combination, triangle is also a piecewise smooth curve because it is the combination of three smooth curves like the pentagon, hexagon, other curves. Simply connected region. What is meaning of a simply connected region? A region is said to be simply connected if any closed curve lying entirely within the region can be contracted. So when you contract that curve, it should be synced to a point. So then we say it is a simply connected region. For example, if you take circle, you can take you can sync that circle to a point. If you take another region, that means the two circles, if you contract this outer circle, then inner circle as remains same, so it is not possible to sync to a point. Okay, that means that second one, this second one is not a simply connected region. It's like that. So let's come to the point. What is the line integral? So an integral is evaluated along a curve is called a line integral. So how to evaluate, how to take the line integral when the given curve is in Cartesian form. So suppose f is the curve in Cartesian form. So that means that p, q, r, the coefficient of f, that coefficient of I, j, k, or p, q, r, that are functions of x, y, z. So then it is a Cartesian curve. Then we say it is a Cartesian curve. So then how to take the line integral when it is the Cartesian curve? So if you take f dot dr, r means this is the position vector at any point. I already told you that r means that position vector at any point. So xi plus yj plus zk, r can be written as xi plus yj plus zk. So dr is equal to dxi plus dyj plus dz. Okay, if you take dot product of f and dr, that is f dot dr, is equal to p into dx. You take the product of the coefficient of I here is p, the coefficient of I here is dx. You take p into dx, like that p into dx q dy plus r dz. So what is the integration of f dot dr along this curve? So that is integration of f dot dr is equal to integration of p dx plus q dy plus r dz. Suppose the curve is in parametric form. So then how can you write the line integral? So as usually we take the coefficients of f is all are that functions of t. So that means it is in parametric form, means you can write p, q, r in single variable. You say that is t. So then if it is r is equal to x of ti plus y of tj plus z of tk, then dr by dt is dx by dti plus dy by dtj plus dz by dtk. So now what is f dot dr now? So f dot dr is p into dx by dt, q into dy by dt, r into dz by dt into dt. So now integration of f dot dr is equal to integration over c p into dx by dt, q into dy by dt plus r into dz by dt. R in other words we can write this is, so here the t1 t2 are endpoints of the curve, and now it is p into dx by dt, q into dy by dt plus r into dz by dt into dt. So here T1 and T2 are the endpoints of the curves. Okay. So this is the method of evaluating line integral when the given curve is in parametric form. Some properties of line integral. If the k is any scalar, it is multiplied with p dx q dy r dz, then we can take k as a common factor and keep it outside from the integration, and we can evaluate that p dx plus q dy plus r dz over c. And similarly, if C is the curve in space, one of two directions, if C is any specified direction. If you take, if you wanted to evaluate in its opposite direction, then we have to write. So that direction, when we are changing its direction, it becomes minus C. So that the integration over minus C is equal to minus of integration over C. So suppose the curve is made up of two different curves, that is C1 plus C2. So if you wanted to evaluate PDX plus QD line integral along C1 C2, C1 plus C2 is the total curve. So that is same as integration of pdx plus qdy plus rdz over c1 plus integration over c2. That is the same. See, as here I am discussing some examples on a line integral. So if f is equal to x square I plus xyj, so now we have to evaluate f dot dr along this straight line. From that straight line is moving from 0 0 to 1 1. As we don't know that curve in which we have to evaluate that integral, first we have to find that curve. So that line which is moving from 0 0 to 1 1, you know that the equation of straight line, when you know the 2 points of the straight line, so we can easily write its equation by using the formula y minus y1 by y2 minus y1 is equal to x minus x1 by x2 minus x1 when it passes through the points x1 y1 and x2 y2. Similarly here, if you consider this 0 0 is x1 y1 and this is x2 y2, if you take this is x1 y1 and if you take this is x2 y2, so then if you apply this formula here, so that is y minus y1, that y1 is 0 by x minus x1, that is y2 minus y1, y2 is 1 minus 0, x minus x1, x1 is 0 by x2 is 1, 1 minus 0. So that is the curve y is equal to x. If if this is y is equal to x, then you take its differentiation, dy is equal to dx. It becomes, from this we can easily write all this f completely in terms of x. That is the uh, that means you can change everything with respect to y also. That means you can change f in terms of y also, then no difference in this. Okay, so x square into I, x into y into j is there, the given f. So now it is x square into I plus x into y, means y is equal to x, so you write x into j, x into x is x square into j. Now dr means dxi plus dyj. What is dy? Dy is dx, so it is dxi plus dxj. So now you take f dot dr. F dot dr is equal to x square I plus x square j dot dxi plus dxj. Now it is x square into dx plus x square into dx, that is 2x square into dx. That is f dot dr is 2x square into dx. You see that limit of the integration is 0 to 1, because so that point that is on straight line x square is from 0 to 1. So you take the limit is 0 to 1, 0 to 1 into 2x square into dx. Integration of x square is x cube by 3. So with limit 0 to 1, apply the limit now. So when you apply the limit, 2 into 1 by 3 minus 0 becomes, now it is 2 by 3. 2 by 3 is the required value of the line integral. Yes, one more problem of the same type. Evaluate integration of f dot dr when f is 2x plus y I plus 3y minus x into j plus yz k along the curve. That curve is x is equal to 2t square, y is equal to t, z is equal to t cube. From t is equal to 0 to t is equal to 1. That means the given curve is in parametric form. That limit, that endpoints of that curve is also given. So that curve here is from t is equal to 0 to t is equal to 1. So as usually we have to find f dot dr. So to find f dot dr, first to take x, y, z in terms of t and dy dz. Dx means differentiation of x is equal to differentiation of 2t square is 2t into dt. Differentiation of y is dy is equal to dt. Differentiation of z is dz is equal to differentiation of t cube is 3t square into dt. So now you take dx becomes 4t dt, dy is dt, dz is 3t square into dt. So now you substitute all this in dr, that is the dxi plus dyj plus dzk. So when you substitute this value, it becomes 4t dti plus dtj plus 3t square dtk. Now f dot dr. So okay, simplifying this by taking dt common factor, it is 4ti plus j plus 3t square k into dt. Now we find f dot dr. F dot dr is 2 into 2t square plus t into I. Okay, this is f actually, because we need to yes, what is f? Yes, what is f? F is 2x plus yi plus 3y minus xj plus yzk. To find f dot dr, first we have to substitute, first we have to reduce f completely in terms of t. So that means substitute x value here, y value here, and y value, x value, and z values in f. So when you take x is 2t square, y is t. So now it becomes like this: 2 into 2t square plus ti plus 3t minus 2t square j plus t into z, that is t cube k. Now f dot dr is this is f dot, this is dr. You take the dot product. It is 4t square plus t into I. Okay, you take its simplification. Okay, take f dot dr here. Okay, come to this step. It is 4t square plus t into 4t plus 3t minus 2t square into 1 plus t to the 4 into 3t square into dt. So now it is, if you multiply this 40 with 40 square, it is 16t cube. T into 40, 40 square plus 3t minus 2t square plus 3t to the power 6 into dt. F dot dr is, when you simplifying this, it look like this: f dot dr 3t to the power 6 plus 16t cube plus 2t square plus 3t into dt. Now you take the integration from 0 to 1. This value of the limit is given in the problem itself, so you just take that limit and take the integration of t to the 6 is t to the 7 by 7 plus 16 into integration of t cube is t to the power 4 by 4 plus 2 into integration of t square is t cube by 3 plus 3 into integration of t is t square by 2. Its limit is from 0 to 1. So when you apply the limit, lower limit is completely 0 and the upper limit is 3 by 7 plus 16 by 4 is 4 plus 2 by 3 plus 3 by 2. When you simplifying this, it gives 277 by 42. So is the required line integral value. One more problem of the same type. Integration over c 3x plus y dx plus 2y minus x into dy along the curve. That curve is given here, y is equal to x square plus 1. It moves from 0, 1 to 3, 10. Suppose in this curve, if you want to take all the limit of x, here if you take the limit of x, x varies from 0 to 3. Here x varies from 0 to 3. If you want to take the limit of y, so here y varies from 1 to 10. Y varies from 1 to 10. Like that we have to take the limit. Okay, so now you take along the line joining. Okay, it is a two parts. First we need to evaluate this line integral along the curve y is equal to x square plus 1, and after that we need to evaluate along the line joining this point 0, 1 and 3, 10. Okay, in first case you take, so pdx integration of pdx. Okay, given curve is in this form, pdx plus q dy. So in first case y is equal to x square plus 1, so which implies that dy is equal to 2x dx. Dx is not written here. Also x varies from 0 to 3. Okay, so because we are taking limit of x, if you want you take the limit of y, but it is risky because when you convert x in terms of y, it becomes square root of y minus 1. So why are you taking risk? So better you follow the easy way. So you write y is equal to x square plus 1, convert all the variables in terms of x. I think that is easy one. So integration of pdx plus q dy is equal to integration. Here x varies from 0 to 3. Substitute the, okay, p is given 3x plus y. Y is x square plus 1. You substitute that value here. Dx plus 2y, that is 2 into x square plus 1. So 2 into x square plus 1 becomes 2x square plus 2 minus x into dy. Dy is 2x dx. So now we simplifying this 0 to 3, 3x plus x square plus 1 plus When you multiply this 2x with these terms, it becomes 4x cube plus 4x minus 2x square. Next step is simplifying this again, 4x, it becomes 4x cube minus x square plus 7x plus 1 into dx. Again, sorry. Now, if you integrate this, it is x to the power 4. That 4 gets cancelled. Minus x cube by 3 plus 7x square by 2 x. Its limit is varies from 0 to 3. So apply the limit. It gives 213. It gives 213 by 2 is the required value of the line integral. Continue some more problems in next hours.